At this time, I would like to welcome Craig Cookson to the hearing. Mr. Cookson is the Senior Recycling and Recovery Specialist at the American Chemistry Council. Mr. Cookson, welcome and thank you for coming. The floor is all yours.
It's on? Great. Thank you, Chairman Lombardo and members of the committee. Appreciate the opportunity to be here today. Always like coming back from here from DC. I'm a native New Englander. I was born in Massachusetts and grew up in New Hampshire, and then lived in Massachusetts, still moving to DC. So always love it here, of course. So I was hoping to talk to you today. The American Chemistry Council, we're the trade association for the chemical manufacturing industry in the United States. I am in the plastics division, so we represent the manufacturers of plastic resins. We also have a group at ACC called the Chemical Recycling Alliance, which represents a group of pyrolysis companies that are working to scale and commercialize, grow their technologies in the United States. So today I was hoping to talk to you about these technologies, as you mentioned, talk a little bit about what they are, what they are not, also the economic benefits potential for Rhode Island, and then also touch on some of the environmental benefits as well. So, and then look forward to your questions. So just have about a 14, 15-minute presentation here. So I think we need to start with why we use plastics in the first place. As we know, plastics are a great material, right? They're very versatile. They can go in tons of different applications, and when they're in automobiles, they help us lightweight those automobiles, so we save energy. We have higher fuel efficiency standards that we must meet. When they're in buildings, they help insulate buildings better, so keep them cool in the summer and warmer in the winter. And in packaging, as Joe knows, food waste is a huge challenge and a big contributor to greenhouse gas emissions through methane and other challenges. And so plastics help us keep food fresh and prevent spoilage and loss. And especially now when we're thinking about the importance of safe and sanitary, plastics play a huge role in that as well. So here's just one of our favorite life cycle examples that shows the migration of packaging from a steel coffee can. My mother used to drink Maxwell House out of a steel can, and then it migrated to a high-density polyethylene canister, and now we find coffee mainly packaged in a sort of a flexible packaging brick. And as you can see here, and you mentioned greenhouse gas emissions in your introduction, that emissions are reduced by 75% over the life cycle, switching from that steel can to that plastic brick. And so it's important to recognize that we have these greenhouse gas emission savings with plastics, but we as an industry recognize that we have to do a better job of recovering these plastics after use and get them back into the economy, especially so they don't end up in the natural environment. So in 2018, our members came together and said, you know, we need to do a much better job. And they agreed to a real high-level goal, a very aggressive goal, that by 2040, 100% of plastics packaging is reused, recycled, or recovered. And really, one of the critical missing elements here, and there's a lot of challenges behind recycling right now, collection and sortation and other things, education, consumer participation. But end markets and the technology needed to be able to do what we need to do is something that needs to scale and grow. So that's kind of mainly what I'll be talking about today. So this is how we see plastics in a circular economy. Right now we take mainly natural gas in this country, turn it into plastics. They have all the different uses that I mentioned. We use and reuse them, and then we collect them after use. And so I want you to pay attention to kind of that critical, it's hard to see there, but the reclaiming and processing stage. And then the connection to the energy chemical resin companies. And that's what these technologies can do, is help bridge that gap to produce liquid fuels and chemicals and other raw materials that the energy chemical resin company can then become the offtake of that, and then we can have a real circular economy, keep those plastics in the economy. So what is advanced recycling that we're going to be talking about today? Well, pretty simple. It's just leveraging chemistry to convert post-use plastics into valuable products. And the outputs can be very versatile as well, depending on the end markets. Virgin-like plastics, specialty chemicals, basic building blocks, so monomers, which are the precursors to plastic polymers, chemical feedstocks like naphtha, which can turn back into different chemicals and plastics as well. And then, of course, low-sulfur transportation fuels, whether for aviation or for marine, as well as highway. And these products, of course, are used as an alternative to fossil-based products, right? So by getting these products and turning them back into these, we reduce our reliance on getting more fossil energy out of the ground. So let's talk a little bit about pyrolysis, because I know that's an important part of today's discussion. So I want to be clear about sort of what this technology is, what it does, and what it is not. So what a pyrolysis process we do is again receive post-use plastics. And these are plastics that have already been sorted at the curb, maybe sorted at Joe's facility or not, source separated. So they may have been separated, source separated once, twice, maybe 3 times before arriving at these facilities. They would prep them by shredding them up, drying them, maybe pelletizing them. And then what they do is they feed the pellets into an extruder and start sort of the melting process, right? So you almost form what's like a really thick toothpaste before you feed it into the pyrolysis vessel. So now this next part is very important. There is absolutely no combustion in this process. So the plastics, this sort of paste, melted plastic, goes into the pyrolysis vessel. You heat it in the absence of oxygen. You continue to heat it, until it melts, and they continue to heat it, and then it turns into gas vapors. So think of basic chemistry, right? We have a solid, a liquid, and a gas. And then they take those vapors and they cool and condense them. And essentially what you have is almost like a synthetic crude oil. And that synthetic crude oil can then be distilled into other products, ultra low sulfur, excuse me, diesel fuel, naphtha, wax products. Wax is very useful. It can go into things like boxes. It can go into shingles. It can go into crayons, candles. Or you can just take that pyrolysis oil, excuse me, having my Marco Rubio moment, and send it right to a chemical manufacturing facility. So I think, again, it's important to sort of stress that there's no combustion in this process. The only combustion is a little bit of natural gas to help heat the vessel up. So process energy, which is no different than the boiler in your house that's producing your heat for the winter or or to cook with. So let's talk about a case example of where this is happening right now. So Brightmark Energy, it's a company that used to be known as RES Polyflow. They merged with a company called Brightmark a couple of years ago. They are building a facility right now in Ashley, Indiana. They got a $260 million financing package. Goldman Sachs is underwriting the green bonds on this project. They're going to be taking this, a big facility, 100,000 tons of post-use plastics annually. Their output is going to be 18 million gallons of ultra-low sulfur diesel and naphtha. BP is the customer for that, and 6 million gallons of wax. And the customer for that is AM Wax. In Steuben County, Indiana, the investment there is almost $140 million. Job creation, excellent. Over, I think, 75% of the jobs right now as they're building, this is a picture there from a few weeks ago, are unionized jobs. So they got the IBEW, the Boilermakers, the bridge and structural ornamental workers, as well as pipe fitters, all there. So good construction jobs for this project in Indiana. Now, I don't have a breakdown of gasification, but it's a very similar process to pyrolysis. The only real difference is it's the same thing. The feedstock might be a little bit different. You're using post-use plastics, but in this case, you can use sort of fiber as well. So maybe paper that doesn't get recycled, wood chips from old fence posting and things like that. Enerkem is a good example of this technology. And what they do with gasification is, again, very similar to pyrolysis, is you're heating this material, but this time, instead of no oxygen, there's a little bit of oxygen, and that's going to impact what is produced. You continue to heat it again until it turns into gas vapors, and then they cool and condense those gas vapors, use a Fischer-Tropsch process, and the basic product is actually what's called methanol, and methanol, as we know, is alcohol. And from methanol, you can go to a lot of different end applications. You can take it to ethanol, and everybody knows we have ethanol, right, as a 10% of the fuel in our cars right now. You can take it to acetic acid, which is vinegar. You can take it to dimethyl ether, which is, anybody's ever gotten a wart on their hand? It's wart spray. You could take it to windshield wiper fluid, so it's got a lot of great uses. So this is really exciting in the different types of chemistry that these technologies can produce. And Enerkem is looking right now at different states. They're looking at Minnesota as an example of a place where they've been talking. They also have a project overseas in Rotterdam as well that they're working on. So again, I think I want to stress is that no combustion here, right? Because at the end of the day, what they're doing is they're not producing electricity or steam. They are producing liquid commodities that you can sell into the commodities market. So what would happen potentially if you were to do this here in Rhode Island and site a facility here? Just using, so we modeled kind of two. We asked ACC's economics department to kind of model some scenarios for us. And you recycle about 2,000 tons of plastics each year. Those numbers are a little bit older. They come from Columbia. A woman by the name of Dolly Shin did a sort of a nationwide look at plastics recycling in the entire country a few years ago. If you took those, about only 25% of the plastics that are going to landfill right now in Rhode Island, you could produce almost 29,000 gallons, you could fuel about 29,000 cars per year in Rhode Island, just based on the plastics that are going to landfill, just on 25%. And a facility would generate about $31 million in economic opportunity each year. If you expanded that, and I know there are thoughts about whether or not you'd want sort of an expansion or a real regional facility, and sort of look to source from Massachusetts and Connecticut and as far away as New York, so drawing a 100-mile radius, you could power about 260,000 cars based on plastics, and I can do the math for you later. And the economic opportunity for Rhode Island would be much bigger. It'd be $277 million a year. And again, these are all numbers that ACC's economics department does. They model this stuff, and we can give you the base study that this is based on. We did an economic study that looks sort of at the opportunity nationwide. So another sort of interesting development is that this is happening now. So as Joe knows well, back in July of 2017, China announced that they were no longer going to take plastics from the United States. And that had a big ripple effect, a little less so here on the East Coast, but really bad on the West Coast, where we hadn't created sort of the capacity to recycle a lot of plastics. And so there's been a supply glut and a lot of challenges. But, of course, when you have a supply, that brings new entrants in the market. And so since July of 2017, there have been 35 projects announced in the United States. That number's actually up a little bit now. Those projects are valued at about $4.2 billion. And I'll talk about a few of those project announcements in a second. These are both from mechanical and advanced recycling. And there's the potential to divert about 2.7 million tons of waste from landfill based on these announcements. So these are some of the investments in circular solutions we're seeing. These are both domestic and international. So just calling out a few in the lower left-hand corner, you'll see the partnership between BP and Brightmark that I talked about before. Over on the right-hand side is Nexus Fuels and Shell. Shell has made a pledge that by 2025, they want to use 1 million tons of plastic a year as feedstock into their chemical plants. So right now, what Shell is doing is they are taking a pyrolysis oil from Nexus and bringing it to their facility in Louisiana to turn into chemicals. Nexus was also a beneficiary of a similar law that's being considered here in Rhode Island that passed back in Georgia a couple years ago. As you can see in the middle, we have United Airlines. They're working with Fulcrum Bioenergy on sort of a lower carbon fuel. Also, kind of at the top there is Agilix, which is going to be working with Delta Airlines to make a jet fuel. They're also working with America's Styrenics. Polystyrene is an interesting one because you can take polystyrene, use pyrolysis, and break it right back down to a styrene monomer, and then make brand new plastics again. So think of your Dunkin' Donuts cup, although I guess they're in paper now, but at least the lids, right, can be broken back down to the basic chemical components and then become a new lid again. So this is stuff that is not, this is actually stuff that is happening right now. So a lot of very exciting things. So if you, as Senator Lombardo's bill from last year, if it was considered, what would it do? Well, really, it would really be a simple change in that ensuring that there's a transparent and statutory pathway to regulate these facilities as manufacturing, not as solid waste management. And there's a reason for that. Number one, of course, is these companies, they are early stage companies, right? Most of them are. So as they're looking to go into a new state, what they're looking for is that regulatory assurance that they're going to be, that they know what the regulatory pathway is going to be going in. Additionally, they're looking for the pathway that makes sense, right? Not something that's trying to regulate a a round peg in a square hole. And so when you think about what are the types of equipment and products and things like that, what makes sense, whether it's manufacturing or solid waste? So we put together kind of a little bit of a helpful side-by-side. So the types of equipment that's regulated under manufacturing, things like extruders and high-temperature reactors, distillation columns, right? That's not something that's necessarily considered under solid waste management regulations, where you're regulating more equipment that's used to sort and separate, a lot of conveyors, things like that. What are the products of the facilities, right? Totally different as well. Under manufacturing, better able to regulate things, the storage of crude oil and diesel, gasoline, fuels, chemicals, waxes, all the products that I talked about. Whereas under solid waste management, their products are mainly baled and containerized materials, right? So bales of plastics, bales of paper, bales of aluminum and steel. What are their potential environmental impacts? Certainly with any manufacturing facility, you're going to be wanting them to get an air emissions permit. You're going to be thinking about what are the discharges to water. Also, again, the storage of things on site. Again, your manufacturing regulations are better able to handle that than the solid waste regs, which are more worried about waste handling, odors, vectors, dust, things like that. And then finally, would these facilities be regulated by the Department of Environmental Management? Well, of course, they'd be regulated under existing manufacturing regulations. So I know, Terry, these aren't necessarily exhaustive, but here's an example of some of the regs that are on the books right now that speak to air, water, and land, and the different types of permits that these facilities would need to get to operate in Rhode Island. So if anybody says these facilities would be unregulated, absolutely not true, right? They'd be regulated under your stringent manufacturing regulations that you have here for, again, air, water, land, and other things. So finally, I just want to touch on the environmental benefits. So I have plenty of studies here that I can leave with the members of the committee today. I want to talk about this one first, though, which is, so back in a couple years ago, Argonne National Laboratory, which is part of the U.S. Department of Energy, they studied pyrolysis of plastics to ultra-low sulfur diesel fuel. And what Argonne National Labs does is they keep something called the GREET model, which is a greenhouse gases, regulated emissions, and energy use and transportation model. So they model over 100 different fuel pathways. So everything from corn ethanol to vegetable oil to fuel to sugarcane ethanol to switchgrass, everything. And so they looked at this and they do a life cycle analysis, and they published it in a peer-reviewed scientific journal article called Fuel. What they found was that compared to virgin ultra low sulfur diesel, you would reduce your fossil energy use by 96%. That's huge, right? Because you're taking plastics that are already that have already been made and not having to go drill for more oil. And you also would reduce your freshwater consumption by almost 60%, because refining is a very energy or water intense process as well. So there are very important quantifiable environmental benefits here. So I'd invite the members of the commission to read that, and we can happily provide that for you as well. So finally, I just want to connect this slide, which is the importance of collecting and reprocessing these plastics after use, with that first slide that I showed of the benefits that plastics have in the use phase. So with that kind of wraps up my official presentation. I'd be happy to take any questions from the committee. So thank you again for having me here today.